All right, welcome to modeling word problems that resemble a sine function. So here we have temperatures from New Orleans, Louisiana, where it says the maximum average monthly temperature is 83, the minimum is 53. The table here is for one complete year. Our scatter diagram that was created here is a 2-year interval. So they typed in these numbers and they typed them in again. So we're getting this curve is 1 year, this curve is another. It kind of looks like a sine curve. All right, now part A is asking us to use the maximum temperatures to determine the function in the form of y equals a times sine of b times the quantity x minus c plus d that models the average monthly temperature. January corresponds to 1, February 2, March 3, April 4, so on and so forth. Excuse me. So the first thing we want to do is we want to take the max and the min values. We're going to find our A and D. To find A, we are going to use the definition of amplitude. Take the high temperature, take the low temperature, subtract the two, and divide by 2. So 83 minus 53, max minus min, divided by 2, 30 over 2 is 15. So that's my A value. To find D, this is where your x-axis is going to cut right through the half of the graph horizontally. So we want to now take the average of those two temperatures, max plus min divided by 2. So 83 plus 53 is 136 divided by 2 is 68. So at 68, we cut the graph right in half. Oh, it looks like my green line might be a little bit closer towards 70. It should come down a little bit. All right, I'm going to end this here. Move that down a smidgen. All right, looking at example number 5, we're going to do some modeling of sine curves with some data here. So here we have the maximum temperature, monthly average temperature, 83 degrees in New Orleans, and the monthly min, 53. We have the entire table for the year, and we have a scatter diagram which has a 2-year interval. So they use this data twice. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. They just put it in again. All right, so we have to write our sine function in its transformational form, a times sine of the quantity b times the quantity x minus c plus d. We're going to let January be x equals 1, February 2, March 3, April 4, so on and so forth. So the first thing we're going to do is find A and D, and we can find that using the max and the mins. The A, your amplitude, by definition, is to take the max minus the min and divide it by 2. It's that positive distance. So if we have 83 minus 53, the distance between those two temperatures is 30. Cut that in half, we have 15. So imagine your sine curve go up to positive 1, down to negative 1. Oh, right here would be up to 15, down to negative 15. That's going to be my distance of 30 degrees. Now, the next thing we want to do is we want to find where is our x-axis that has been shifted to cut your sine curve in half. So change the minus to a plus. You're finding the average of these temperatures. Max plus min divided by 2. 83 plus 53, 136 divided by 2, 68. So if I drew a line through here, this is where my x-axis has shifted up to. All right. The next thing we want to do is now we want to look for B and C. B is going to be your period length. C is how far you shifted left or right. Well, here's where I start my sine curve. On the x-axis, up, down, complete. So therefore, I need to figure out what point I'm at here. So this is when 1 is at 53. This is 2, 3. I am at point number 4. So with that being said, I have now taken this point, which is supposed to be down at the origin, shifted it to the right 4, and up 68. So I just found my C value. We have A, we have D, we have C. Now, as I mentioned earlier, this is the beginning of my sine curve. Here is the end of my sine curve right here. So if we count this out the rest of the way, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I get to 16. That's that point right there. So here's my sine curve. So to find my period length, 16 is the x-coordinate ends at, begins at 4, subtract that, that's 12. Okay, wait a minute, that makes sense because it's a year's worth of data, 12 months. So take P equals 2 pi over B, set it equal to 12, and solve for B. Okay, multiply the B to the 12, now divide the 12 into the 2 pi, reduce pi over 6, there's my B value. So we now know A is 15. We now know B is pi over 6. We know C, it's a 4. We know D, it's 68. Write the equation, just substitute in the values. All right, next part B. Use your graphing calculator to graph f of x from A on the same grid as the values found in the table. We're going to make this picture here. All right, so I'm going to go grab my calculator here. All right, well, let's see. I think I have this thing doing screenshots first. So here we got to put all this data into L1 and L2. So I'll use my calculator to demonstrate how to get there. All right, let me move this down just a bit. There we go. You want to hit Stat, Enter on Edit. Okay, I already have the data put in. There it is. You can scroll down to see all my values. Okay, so again, let me move this over to my other monitor. Next, what we want to do is change your window to match here. So hit the window button, Xmin 0, Xmax 24, counting by ones, Ymin 50, Ymax 85, counting by fives. That's your Y scale right there. So if we want to plot those points, you're going to have to turn your plot on. So to do that, second Y equals. Plot 1, right now it's off. I hit enter. Now I can highlight the word on. We're good to go. So here's my scatter plot. It's defaulted to L1, L2. Right now we're going to make black dots. You can change the color. You just put the cursor on there and change your color. So now I'm going to hit graph. And whoops, I forgot to turn my equation off here. Let me do that real quick. And there's our points. I got a step ahead of myself. So entering this into Y1, there's that screen right there. You saw my graph already produced that. That's the screenshot. We're putting this into Y1. Okay. And just to show you that screenshot, there it is. We just now have to turn it on and then graph it, and there's that picture of my screenshot right there. Okay, Now that we have this data all in our graph, now we're going to go to part C, where we're going to let the calculator make the regression. So we kind of used our knowledge of transformations to help find our values. But now we're going to let the calculator do it. So what you want to do is you want to go back to your home screen, hit Stat, cursor over to the Calc drop-down window, and Option C. All right, so let me get my calculator here. I don't know why it changes the size of my calculator every time. All right, so second mode, back to the home screen, Stat, go over to the drop window Calc, and we need to scroll down until we get to C. Sine regression, we hit Enter. All right, so we have the 3 iterations. We're in L1, L2. We're going to let the calculator do all the work. All right, so let me get caught up on my clicks here. There was C. Whoops, I want to store that regression. Let me go back to my calculator and show you how we're going to store that. Every time it changes, it's weird. Okay, come on. There we go. All right, we're going to go down to Store Regression. And if you hit Alpha Trace, you get a pop-up window with all your y's. Well, I put my equation for y1 in for sine. We're going to go down to 2, hit Enter, and now it's going to store it there. And we'll hit Calculate. It crunches it out. Here's our data. All right, so I'm going to go to my screenshots for those. So here's the same thing. Now looking at my values here, A was 15.14. We had just 15. B is 0.52086, da 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 da. So I went to my home screen of my calculator. I typed in pi over 6, and it's 0.523. Pretty close in our estimates here. Our C, though, that's kind of a big disappointment. All right, RC was a -4. They have a -2. Oh, wait a minute. Wait a minute. Why is it so different? Because they didn't factor out the B. Okay, so if I go back to my calculator here, second mode, as we said, we take that, we factored out the pi over 6, and if I multiply that by 4, so second pi, we'll say divided by 6, and then multiplied by the 4, there's that 2.09. They had the, well, negative 2.19. I just didn't put the negative on it. So our C is very close. We had 68 for D. They have 69.67. Reasonably close with everything. So now, graph, you go to y equals, just to show you what's there. It has the calculator's version, lots of decimals. We graph it, and there's the, in red, the calculator's version of the sine curve. Pretty good with what we have going there. All right. Okay. And there's the graph, the screenshot. And that's how we do sine regressions in our calculator.